Hello everyone, welcome to our 5G Business Open class. In my hands, I have a brand new Naked Eye 3D tablet. This also signifies today's topic. The Naked Eye 3D industry chain is quickly maturing. Breakthroughs in cloud, rendering high-quality computing power, and real-time generation of 3D digital humans have brought personal immersive experience to a new level. An increasing number of devices, including mobile phones, tablets, laptops, and TVs, now support Naked Eye 3D. Compared with 2D videos, Naked Eye 3D can stimulate 10 times more traffic. Today, we invite two Naked Eye 3D experts to join us. One is Mr. Wang Ling, General Manager of 3D Display Consumer Application, BOE.
Hi everyone, I'm Wang Ling.
The other is Mr. Li Wei-Wu, Naked Eye 3D Technical Expert from Huawei.
I'm Li Wei-Wu from Huawei.
Mr. Wang, we know that BOE is a leader in the display industry and you're the head of the BOE 3D business. So what are the current status and future trends of 3D display technology?
Alright, let me answer that question. First, it is worth noting that 3D display technology is not new. It has been developing for over 10 years. Currently, 3D display is based on binocular parallax. Specifically, a person's eyes obtain two images with slight parallax. The images are then automatically fused into a 3D image within the brain. Now, there are four mature technologies in the industry that make this happen: cylindrical grating, directional backlighting, TN liquid crystal grating, and liquid crystal resin lenses. In terms of cylindrical grating, the 65-inch 3D display that supports hologram-like video calling, Sony's 27-inch Naked Eye 3D display released last year, and the outer screen of the Vision Pro glasses all use the technology. This technology focuses solely on 3D. It has no application regarding 2D, including picture quality or anything else. That is one technology. Another is directional backlighting. For example, a 12.4-inch 3D tablet was released last year, which uses this technology. It is also known as diffraction grating. Nubia's tablet provides excellent experience, combined with various applications. It is the industry's first consumer product of its kind. A third is TN liquid crystal grating. This technology is also heavily promoted by BOE. Overall, this technology is mature and has advantages in costs. We have developed our own TN liquid crystal grating technology. We are also working on it with other vendors. The fourth is liquid crystal resin lenses. They are used in Acer's 15.6-inch laptop and Lenovo's Naked Eye 3D display. Launched at IFA in September 2023, this technology, according to our assessment, has great potential. In addition to LCDs, it can interconnect with OLED displays. This gives it great technical scalability with few restrictions. It is also a technology BOE will focus on in the future. In the future, we will see next-gen light field display technology. This technology combines binocular parallax with motion parallax. However, it will place higher requirements on 2D displays. This means overall system reconstruction, including the configured driver chips. It thus may take 3 to 5 years to mature. That's all about the development paths and overview of the Naked Eye 3D technology.
Thanks, Mr. Wang. It seems clear that there are many Naked Eye 3D technologies and solutions being developed to provide a better experience and better display effects. My second question is, from the consumer perspective, and about how Naked Eye 3D devices and their matched content are equally crucial. So I'd like to ask Mr. Li this question. How can we experience 3D anytime and anywhere? And in which scenarios does Naked Eye 3D bring consumers special experience?
I think Naked Eye 3D has mature applications in four main fields. The first is VOD. Why is this? Thousands of 3D movies already exist, some of which are filmed with binocular cameras while others are converted from 2D based on AI. We can watch these movies at home anytime using naked eye 3D devices such as tablets, TVs, or phones. That means we can experience immersive 3D movies without going to the cinema. In addition, we can reuse existing VR content. Some users may not want to wear helmets as they can be heavy. Naked Eye 3D devices give them an alternative way to access various 3D movies and content. The second field is live streaming. This includes two scenarios. One is live commerce, which is a very popular industry. If it is combined with Naked Eye 3D, users can better perceive products in 3D, allowing them to make better choices. The other is live sports. For example, during a football match, users may get the impression that the ball is flying out of the screen, thanks to 3D technology, providing them with immersive viewing experience. The third field, I think, is New Calling. This is also a service that China Mobile has been promoting. In addition to the calling function, it has a video feature. This will offer better user experience and stimulate traffic growth. By adding 3D to New Calling, we will help operators provide a whole new calling experience that is more true to life. The last field is vertical applications. We can increase user stickiness in many industries such as gaming, education, design, and healthcare by bringing users more immersive experience.
Following Mr. Lee's introduction, I'm really looking forward to the arrival of Naked Eye 3D. It feels like we will soon transform from the current 2D world into one of 3D. I'd also like to ask Mr. Wan a question. As I have mentioned, from device development to attractive content, we're facing a challenging question. How can we generate and guarantee 3D content to guide consumers to enter the new industry?
Mr. Ling just mentioned some popular 3D content applications. BOE is also promoting Naked Eye 3D from the industry perspective. Actually, we divide 3D content generation into three aspects so that users can better access the related content. The first is direct shooting. The second is 2D to 3D conversion. The third is native 3D content, based on virtual rendering. In terms of direct shooting, we know that the movie Avatar was directly filmed with a lot of binocular 3D cameras. But the costs were remarkably high. Over recent decades, only a few such 3D movies have been available in the cinema, but they have certainly offered viewers fantastic experience. The second scenario is glasses in the endoscopic surgery in the medical field. They use direct binocular shooting so that doctors can better see, or more precisely see, patients' lesions. This gives better insight into things like where pliers or scissors should be used. Such things must be clear, otherwise, surgical accidents may occur. These glasses are already being used in the medical field. The third scenario is user-generated content. Consumers can directly shoot 3D pictures and 3D videos and make their own creations. In China, Tmall has already launched a 3D experience space, which features many products like watches, bags, and shoes. All of these items are shot for 3D reconstruction. Instead of being virtually rendered, this involves intensive workloads. So, this is self-generated user content, or procedural content generation, PCG. In the future, this will bring a wider range of benefits to consumers. That is, direct shooting. The second aspect is 3D conversion. A massive amount of the movie and TV content we have now is 2D. So how can we make this 3D? In fact, 2D to 3D conversion technology does exist. In the past, for example, if we made a 3D movie in China, it took about 3 months for a team of 100 people at a cost of around CNY 3 million to CNY 5 million. The movie Titanic is a good example. In 2018, its reproduced version was completely converted from 2D with fantastic 3D effects that cost USD 18 million. This was very expensive. But today, there are many conversion technologies in the industry, such as AI-based, fully automatic conversion, cloud-based conversion, and local conversion that consumes high computing power. Cloud may be an ideal trend for future development. Therefore, 3D conversion is inevitable, given that 3D content is currently lacking. As such, in the short term, it is a very good solution for content growth. The third aspect is native 3D. Virtual rendering can be used for 3D animation, 3D games, 3D virtual training and education, and other applications. During 3D modeling, we can add various outputs and virtual pilots from different angles to obtain different pictures. But this involves a problem. For example, for movies, we need the source. For gaming, we need the copyright party, including software used by designers. We need software support from the original vendors to interconnect with the 3D display, like making a plugin. Then we can put existing native 3D content on display. That's all regarding the three aspects of content generation. As long as the upstream and downstream are fully interconnected, especially the involvement of the original vendors, industry development can be boosted.
Our thanks to Mr. Wang. We've learned that there are three ways to produce content in Naked Eye 3D. The first is converting existing 2D content to 3D to quickly guide the consumer market. The second is achieved through direct shooting. As Mr. Wang just mentioned, mobile phone capabilities can support now. The third is professional content production. This can create more high quality and epic movies and photos. Actually, I've also been involved in many exchanges with operators in terms of new Naked Eye 3D products and business. They are very curious about such applications and ask us about the benefits Naked Eye 3D can bring to networks in addition to greater user experience. In this regard, I'd like to share with you details of our analysis, discussions, and understanding. For Naked Eye 3D, let's start with the simplest 2D to 3D conversion, as Mr. Wang mentioned. As an example, it can boost the traffic by 1.3 to 1.8 times. In other scenarios that Mr. Wang mentioned, like professional production of games or high-definition movies, traffic growth would be remarkably higher at around 10 times more. So, from this point of view, we're looking forward to Naked Eye 3D. I think our display technology, content production, applications, and operators' network capabilities will all evolve to make it reality. Last, I have one more question for you. With Naked Eye 3D approaching large-scale application in the next 1 to 2 years, or maybe slightly longer, what breakthroughs do you think it will achieve in terms of experience and ecosystem? And what challenges will it need to overcome, Mr. Wang?
I'd like to start with the cooperation with BOE or some of our customers. For example, at the end of last year, we developed the world's largest 27-inch Naked Eye 3D display for Lenovo. It supports switching between 2D and 3D during daily use. As 2D scenarios outnumber 3D scenarios, compatibility for both must be considered. Meanwhile, relying on our hardware development, 2D and 3D switching technology is mature. A larger product size will bring more immersive experience. So this product is a great combination of hardware and content. Another example is Sony's 27-inch Naked Eye 3D display. What's the difference between this and Lenovo's? Sony's does not support switching between 2D and 3D, but it solves one of the fundamental problems. By using extreme eye tracking technology, it uses an industrial 1,000-frame camera. This camera is rarely used in the consumer or other fields. For Naked Eye 3D to be a reality, It must keep up with users' eye movements to ensure the best experience. So, user experience will not be compromised, even when you are moving. Its CPU computing power is also a highlight. It offers excellent experience and provides great confidence to ecosystem partners who are developing naked eye 3D solutions.
Mr. Lee, how about your key projects?
As Mr. Wong Lee mentioned just now, Lenovo's 2D and 3D switching and Sony Eyes tracking cameras. Existing Naked Eye 3D is based on binocular parallax. If there are only two pictures, then you see information only from two pictures. 3D reconstruction restores the information of real objects, allowing us to see their different aspects in different positions. Through collection, encoding, compression, transmission, decoding, and display and playback, this involves several key technologies. How can such a huge amount of data be transmitted at low latency? It requires encoding technology. What's more, the industry is now using a 65-inch 8K display. In the future, this may be upgraded from 8K to 16K and combined with light field technology to restore even more realistic 3D information. I think this is the trend of next-gen technology. How can we focus on streamlining the upstream and downstream industry chain with hardware, software, standards, and ecosystem to perform this task effectively?
Thank you for sharing your thoughts on our current Naked Eye 3D industry and future prospects. As the father of media studies, McLuhan once said, any technology tends to create a new human environment. Naked Eye 3D brings us immersive sensory experience and will inevitably revitalize our social, entertainment, education, and cultural perceptions. However, this will require higher network transmission capacity. From our previous estimations, from 2 Mbps and 10 Mbps to 20 Mbps, depending on the content, there will be increasing demands on bandwidth. At the time of 5G and 5.5G construction, we hope that Naked Eye 3D will be further developed to help bring our imaginations to life and become a pillar application in the 5G era. Thank you all for joining us. That's all for today's 5G Business Open Class. Thanks for watching. See you next time.